Julia, we get the door, please. Okay. So let's start with, I'm going to do some examples of what you're going to see on your test. Okay? The first thing, and we did this right at the beginning of the year. Okay? This is your mid-year mastery test review. Okay? And we will get through as much of this as we possibly can. Okay, but what you need to remember, all of this stuff, you can go back and look at through your notes. You can go back and watch videos if you want to. Okay. The first thing we need to remember is, this is order of operations. Oh, I'm sorry, guys. It's on, but it's not on the right source. That should be the one. Bam. Bam. There it is. Okay. All right. So order of operations. Okay. When we do, and you would be shocked at how many miss. The first problem on your mid-year mastery is an order of operations problem. I will bet. No, I'm not going to bet, but I'm going to say that probably in the past, almost more than half missed this first problem. Okay. Why? Because you don't do it in the right order, right? Okay, you guys want to be done, you want to get done with this fast, okay, so you don't do the right steps. What is the first thing you look for in order of operations? Sam? Parentheses. You have to simplify parentheses first, okay? What's the second thing? Trey? Exponents. Good. And here's where you guys get tripped up, okay? Why do I put them on the same level? Multiplication or division, whatever I see first from left to right, okay? Some people think, well, there's multiplication, but if it falls after division, it doesn't mean you do it first, okay? It's whatever you see first from left to right, okay? This is multiplication, division, left to right, okay? And what about the last two, addition and subtraction? Okay, these are always the last things. But if there's an easy addition thing in there somewhere, like if you saw 2 plus 1, okay? So many of you guys just say, well, I'm just going to take care of that real quick. But if it's not in the order of operations, are you going to get an answer correct or incorrect? Incorrect, okay? So addition and subtraction, and this is also what? From left to right. It doesn't really matter which one you see first. It's whatever you see first going from left to right. Okay, I don't need to do an example of that, right? Okay. If the next thing you're going to need to know is about exponents. Okay, and we spent a great deal of the first chapter on exponents. Okay, the first thing about exponents, if I have exponents and I'm going to evaluate exponents, what does evaluate exponents mean? Give me a number. Jordan, give me a number.
4.
Okay. If I said 3 to the 4th power, okay, what answer do you think, what is the most common incorrect answer that you think I get? 12. Okay. If I had 12, what did that person do? Multiply 3 times 4, right? Which 3 times 4 is 12, but 3 to the 4th power is not 12. This means I'm going to what? If I say evaluate, think about what evaluate means. That means what? Find the value. Okay, in other words, figure out how much this number is. So this is 3 times 3 times 3 times 3. 3 times 3 is what? 9. 3 times 3 is 9. 9 times 9 is what? 81. Okay? That's what I'm talking about with evaluate. Okay? Now, what if I have a negative here? You guys get confused with this. If I said negative 2 to the 3rd power, okay? All this means, this doesn't change anything. My exponent is still what? My exponent is still positive. My base is negative. So this doesn't change anything. It still means I take negative 2 and multiply times itself how many times? 3 times. This means negative 2 times negative 2 times negative 2. Negative times a negative is what? Positive 4 times negative 2 would give me what? Negative 8. Now, what do I mean when I say you guys get confused? Okay, if you see this, That's not the same thing, is it? Okay, that in that case, and you are going to have some with negative exponents, I have a negative exponent. I cannot, number one, I can't leave my exponent negative. How do I get rid of a negative exponent? Who remembers? So many of you guys forget this, and we did this back in August. How do I get rid of a negative exponent? Anybody remember? Put it under 1. Thank you, Hannah. So I put this under a 1. So I have 1 over negative 2. That base stays negative, but my exponent is no longer negative. What's that 3 become? I mean, negative 3. It becomes a what? Positive 3. So now I have 1 over negative 2 times negative 2 times negative 2, which is what? Positive 4 times negative 2, which is negative 8. So all of this is 1 over negative 8. Okay? Some of you guys, when you see this negative exponent, you just evaluate and you put a negative sign in front of it. That's not what you do on this. Okay? 3 different things that you're going to see on your test. Yes, Jane?
If you have a negative 2, negative 3, say, can you just do it and then put a 1 over it when you're done?
I mean, you could. You mean do negative 2 to the 3rd power?
Yeah.
Yes, you can. I'm just showing you what it, I mean, technically, yes. Okay. All right. Are we good on that? Yeah? Okay. What about now? Continuing with exponents. If I am multiplying exponents, okay, for example, let's say I have 7 to the 3rd times, we'll say 7 to the 5th. Okay? Who remembers when I multiply exponents, what do I do with those exponents? I add them. This means 7 and 3 plus 5. I did not say evaluate. Okay? If all I'm doing is simplifying this, I don't want to find 7 to the 8th power. This is good enough for my answer. If I said to evaluate, then you have to evaluate. But all I'm asking for you to do is simplify this. 7 to 8. Now, is that the same thing as this?
No.
It's not the same thing as that. When I have a parenthesis separating these exponents, this means 7 to the 3rd raised to the 5th power, right? So what does that mean? In essence, that means I'm taking my 7 to the 3rd and I'm multiplying it times itself how many times? 5 times. Now, I don't expect you to write all of this out, but I'm just trying to illustrate what that means. So this means 3 plus 3 plus 3 plus 3 plus 3, which is 7 to the what? 15th power. An easier way to do that is just to take these two exponents and do what with them? What does a parenthesis typically imply in pre-algebra? Multiplication. So if I multiply those exponents, that would just be 7 to the 15th. Okay? Do you understand? Do you understand the difference between those two? Okay. All right. What if I have, let's just take these same numbers. I have 7 to the 3rd divided by 7 to the 5th. Okay? What is my rule if I'm dividing exponents? And by the way, this only applies if I have numbers with the same base. If I don't have numbers with the same base, I can't do it. Okay? I actually have to find the value. But I have the same base here, right? So what do I do? Does anybody remember what I do if I divide exponents? What do I do, Jane?
You just divide the exponent.
Great guess, but no. You subtract. Thank you. So this is 7 and 3 minus 5. What is 3 to the negative? 3 minus 5?
2.
Huh?
2.
What kind of 2?
Negative.
Negative 2. So this is 7 to the negative 2nd. Now, I can't leave this because my instructions are to simplify. What does that mean? I can't simplify this. Because there's what?
A negative.
How do I get rid of it? So 1 over 7 to the 2nd, okay? You're going to see stuff like that. Are we good on that? Okay. Continuing with exponents. Part of exponents is scientific notation.
Wait, so to the last answer, then it'd be 1 over 7.
No, it would be 1 over 7 to the 2nd. You don't have to evaluate it. If we were to evaluate it, it would be, if we were to go all the way there, it would be 1 over 49. But we can just leave it 1 over 7 to the 2nd. Okay. And I'm not going to get it wrong if you did 1 over 49. Okay, scientific notation. Who remembers what scientific notation is? What is it, Jane?
It's how to express, it's a number expressing a really big or really small number.
Yes, a way to express really big or really small numbers in powers of what? 10. Okay. Powers of 10. Okay. So if I had, let's see, Julia, give me a number in the 10,000s.
64,000.
Okay. If I had 64,000 And I wanted to express this in scientific notation. Who remembers the process? I scan this number from left to right. And the first number I come across that's not a what? A 0, or between 1 and 10, which is in this case what? 6. Okay? And what comes after that 6? I put a what? A decimal, and whatever other non-zero numbers that are there, right? As long as they're not non-zero numbers that are separated by a 0. In this case, what's the only other number I have over there? 6.4. Now, keep in mind, this number right here, what is my rule with that number? It has to be between what? Has to be between 1 and 10. Okay? If I do not keep that between 1 and 10, it's not in scientific notation. Okay? This is between 1 and 10. So am I good to proceed?
Yes.
Yeah. And then I multiply this times 10. And how do I determine this exponent? Can I just count the zeros here? That's a common mistake, isn't it? If I just count the zeros, that's not going to work. How do I figure out where I put what the exponent is going to be? Anybody remember? Where did I put my decimal? Between what two numbers? I put my decimal right there. All I have to do now is count the digits to the right, which is how many? So this would be 10 to the what? 4. What if I have one like this? Do I do this the same way? Left to right. What's the first non-zero number I see? What comes after that 8?
3.
Point, and then what? 3 times 10. Now, here's the difference. This time, wherever I put my decimal, which in this case was right here, I have to count to the beginning of the number where the decimal was. But in this case, I don't go to the right. Which direction am I going? And anything on the left is going to be what?
Where are you going to go?
Because I have to count to the beginning of the number. Okay? Because it starts with the decimal. So this one is 1, 2, 3, 4. But this is no longer 4. This is now a what? A negative 4. Okay? Do you understand the difference? Okay?
Yeah,
You do not. No, this is good. All we're doing is writing it in. These are in standard form. We're writing them in scientific notation. Okay? So let's do the opposite of that. Let's take some numbers that are in scientific notation and put them into standard form. Okay, let's say I have, we'll say 2.57 times 10 to the 6th. Okay? Here's a mistake a lot of people make. They do this. Okay, what did that person do?
myself.
Sam?
You added 6 zeros.
You just add 6 zeros. Okay? Is that going to work?
No.
No. Okay, so let's get rid of that. We don't want to do that. So I'm going to take this 2.57, all right, and I'm going to put my pencil right here on this decimal. Okay? Is this exponent positive or is it negative? It's positive. So anything on positive, or if we're thinking like a number line, it's going to go where?
That way.
That way. Well, which way?
Right.
To the right. So I'm going to move it 1, 2, 3, 4, 5, 6. What do I fill in these empty spaces with? Zeros. Okay, and this looks a little messy, so we would rewrite this. Is that correct? Is that the same as what we had when we added 6 zeros? No. Okay, that's the correct answer, right? Okay, what if I have one like this? Let's say take those exact same numbers. Let's say I've got 2.57, but this is times 10 to the negative 6th. Okay, I'm still going to start with that number, 2.57, but this exponent is what? Negative. So what direction am I going to go now? Left. I'm going to go 1, 2, 3, 4, 5, 6. What's going to go in front of my number? Before I even start, what's going to go up here? The decimal. And then I fill in my zeros here. Okay? Does that make sense? Do you guys remember doing that? Okay. What is a perfect square? By the way, this is the next part. This is roots. What's a perfect square? Somebody tell me what a perfect square is. Jordan, what's a perfect square?
Like an exponent and a base that are same.
Just give me an example, like a number.
2.
2's not a perfect square. Lincoln. 25 is a perfect square. Why is 25 a perfect square? Because 25 has an integer that when I multiply it times itself, it equals what? 25. Okay? Why, when Jordan said 2, why is 2 not a perfect square? Are there 2 numbers I can multiply to get 2?
No.
No. Are there 2 numbers I can multiply to get 4? Yes. What about 5?
No.
6?
No.
7?
Wait,
8?
6, yeah.
6? No.
Oh.
9? What about 9?
Yes.
Yes. Okay, so you kind of remember what a perfect square is. Okay.
Yeah.
So if I have 25, and if I said I wanted you to write 2 square roots of 25, are there 2 square roots of 25? What number can I multiply times itself to get 25? 5. What else, Trey? Is there another number I can multiply times itself to get 5? Are you sure? Say it, Noah. Negative 5. You know, what's another way I can write this? Do you guys remember? You guys remember that? Plus or minus 5. Okay. If I write plus or minus 5, that means plus or
Can we
minus.
still write 5 comma negative?
You can write it either way.
Wait, I don't understand why you can get a negative one too.
Because what's negative 5 times negative 5?
Positive.
Positive 25. Okay. So every perfect square technically has 2 square roots. It has a square root that's negative and a square root that's what?
Positive.
Positive. Okay. Right?
Yes.
Yeah. Now, can I have this? What does this mean? This means the negative square root of 25, which is just going to be what? Negative 5. Can I have this?
No.
Oh, sorry. Can I have that? No, because there's no 2 numbers that I can multiply to get a what? A negative number, right? Can you do that? There's no number I can multiply times itself, because anytime you multiply negative times a negative by itself, times itself, are you going to get a what? Positive, or the same thing with positives, right? Okay. All right, the other thing you need to remember, what if I have something like, let's say, this. Now, these are not hard. They look hard because you see a fraction inside of a radical sign, and you get freaked out. But these are easy. Why? What do you notice about those 2 numbers? They're both perfect squares. What's the square root of 64? What's the square root of 81? That's it. Okay? Right? Right?
Yeah.
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 Now, what do you notice is different? Can I do that? Is 8 a perfect square?
Yes. No, it's not.
No, it's not. But what if I had a 3 out here? What does that mean? Somebody tell me, what is the meaning of that?
It's cubed.
That means what is the cube root of 8? Is 8 a perfect cube?
Yes.
In other words, is there a number that I can multiply times itself? What does cube mean?
3 times.
Tres times. So if I multiply times itself 3 times, I should get 8. Well, 1 times 1 times 1 is 1, so it's not 1. What about 2?
2.
What's 2 times 2?
4.
What's 4 times 2? 8. So what would the cube root of 8 be? 2. Now check this out. Is there such thing as that? Why?
Because
Jackson?
3 of them.
If I did, is there such thing as a number I can multiply times itself 3 times to get a negative?
Yeah.
What is negative 2 times negative 2? Positive 4. What's positive 4 times negative 2? Negative 8. So is there such thing as a negative cube root? Yes, there is. Okay. Remember that? Yo, Jane.
What makes 8 a cube root? I mean, perfect.
I don't know why I put a 3 there. I'm sorry. It's Monday, guys. Sorry. What'd you say, Jane?
What makes 8 a cube root?
What makes 8 a cube root, or what makes 8 a perfect cube?
Perfect cube.
It has a cube root that is an integer. In other words, 2 times 2 times 2.
Oh, okay.
Make sense? Have I put anything up here that we haven't done before? Nope. Okay. What is a one-step equation? Oh, sorry. Let's go back to this. Equations.
Wait, wasn't scientific notation number 3?
It was part of exponents. I just counted that as part of exponents. All right. Oops, sorry. Okay, scientific notation. I'm sorry. One-step equation. If I have this, Kemper, are you paying attention? What happens here? How many, when I say to solve for x here, you want to know what I get sometimes?
What?
I'm not kidding. Why would somebody give me this? Because they're trying to get rid of that negative 5 by adding 5. Is this correct?
No.
Okay, why should you not miss an equation problem where you're solving for a variable? Is there a foolproof way to check these? If I plug in 25 for x, first of all, what does negative 5x mean? What does that imply? What operation? Does that mean negative 5 plus x?
No.
What does it mean? Negative 5 times x. And if I replace that x with 25, is negative 5 times x 50 or 20? No. So this is not what we're going to do. This means negative 5 times x. How do I undo multiplication? You divide. And I divide by whatever is being multiplied by that variable. In this case, what's being multiplied times the variable? Negative 5. Okay, so this cancels. I have x. What's 20 divided by negative 5? Negative 4. Okay, what if I have one like this? X plus 2 equals negative 5. This is also a one-step equation. But what's happening to my x here? What are we doing to that x? We're not multiplying it by 2. What are we doing? We're adding 2. How do we undo adding 2? We subtract 2. So we would take away 2, we would take away 2, and x would equal negative 7. What if I have this? What's happening here? What is this? We'll make this a negative. Two-step equation, right? You guys remember that? So I put this, whatever is touching that variable, in a box. What's outside that box? What's outside the box? A plus 4. How do I get rid of a plus 4? I minus 4 here, and a minus 4 here. Those cancel. I have negative 2x equals, what's 12 minus 4? 8. How do I solve this? Divide each side by what? By what? By negative 2. And what does x equal? Negative 4. Okay, do you remember doing that?
Wait,
Okay.
how did you get?
Because 12 minus 4 is 8. When I got rid of that 4, I took away 4 from one side and I took it away from the other side.
Right.
Okay, what if I have something like this? Can I erase that? Do you guys have that? Bless you. Are we good?
Yes.
Okay. What if I have something like this? Okay. What am I going to do on this one? In order to solve for x, this is not even, it's a little bit more than a two-step equation. But what do I need to do in order to solve this? Before I box the 2x, I look to see if there's anything I can combine. Can I combine this and this? Because they are what? Anybody remember what that's called? Like terms. So 2x plus x gives me what? 3x plus 3 equals 15. What do I now have? What is this thing? Two-step equation. How do I get rid of this 3x? I can't do anything yet. I got to get rid of plus 3. How do I get rid of plus 3? So minus 3 on both sides. So I have 3x plus, 3x equals 12 divided each side by what? By 3. And what does x equal? 4. Okay. You remember that? What if I had this? Can I erase this?
Wait, okay.
Good.
Wait, so where'd the so where'd the 2 go?
Which two?
2x.
I added these together because this is 2x and 1x.
So that added 1 and made it 3x?
Mm-hmm.
Wait, so with 15 minus 3, then you're just subtracting and you take the answer, you take 12 and then divide
Yeah,
by 3.
because I've changed it. I went from a multi-step to a two-step to a one-step solved. Okay. Yo.
So since the 2 is there, would there ever be a bigger number on the test?
Might be. All right, look at this one. Let's say I've got this. 3x plus 4 plus x equals okay. What's different about this one? I not only have to simplify this, I have what? I have variables on what? Both sides. Okay? So can I combine 3x plus x? And that gives me what? 4x plus 4 equals negative 2x plus 10, right? Well, I need to get these variables on the same side. Who remembers my rule? Or it's not even a rule, but my advice. Which one do I get rid of? The one with what? The one that has a lower value, a lower coefficient. So if I add 4x here, I'm sorry. If I add 2x here and I add 2x here, that gives me 6x plus 4 equals what? 10, right? And then I'm going to, this, what did I turn this into? A what? A two-step equation, right? So this is in my box. How do I get rid of plus 4? I subtract 4. I subtract 4. Then I have 6x equals 6, right, Kemper? Okay. Divide each side by what? 6. So what does x equal? What's 6 divided by 6? 1. Okay. And if I go back and plug in that 1, would it work?
What are these called?
These are multi-step equations. Okay. If I plugged in that 1 for x, that means 3 times 1. What's 3 times 1? 3. Plus 4. What's 3 plus 4? 7 plus 1 is what? 8. Now let's plug it in on the other side. What's negative 2 times 1? And what's negative 2 plus 10?
8.
Does 8 equal 8? So did we solve this correctly? Yes, we did. Okay. Yeah, finish copying, because you got to know how to do that. Okay, what about something like this? What's different about this one? What do I have to do to solve this one? Who remembers? What's this called? Jane. She's making the hand gestures. Jackson?
You have to do the things in the parentheses.
What's that called?
No, you, the
Rhymes, okay, rhymes with distribute.
distribute.
Yes, I have to distribute. Is that what you were talking about, Jane? Okay, so I separate these terms. That's the only way to get rid of those parentheses, right? So what's 2 times 2x? 4x. 2 times negative 4 equals 16. What do I have here? Two-step equation. So add 8. Add 8. I'm left with 4x equals what's 16 plus 8? 24. Divide each side by 4. What does x equal? 6. Okay. Why aren't you writing this down? Come on. Okay, do you remember doing that? You're going to have some like this on your test. Okay? Are we good on that? Okay, I got to finish this up, so you guys need to pay attention. No! Calculators. 24 divided by 4.
No, I know, I'm just saying.
Yeah, no, I'm just saying. No, you don't need calculators.
Can we use
Okay.
our notes?
Huh?
Can we use our notes?
No.
Wait,
Hurry up. Hurry up, guys. You got to go. Let's go chop chop. You're not chopping fast enough.
okay.
Wait, I'm not.
Okay. Are we good? Are we good? Are we good? Okay. All right. Next part you got to know. Okay. Remember, pay attention. I need to know how to do graphs. Okay. And specifically with graphs, I'm talking about slope intercept. What is slope intercept form? Do you guys remember? Let me give you a clue. Slope intercept.
Oh,
Slope
Slope.
intercept. Why is it called slope intercept?
slope then intercept.
Y equals mx plus b, and it's called, oh, I made that messy,
Wait, do we
sorry.
have to remember this for the test?
Oh yeah, that's what I'm showing you. Okay, what does that mean? Well, slope intercept. If I gave you this equation, y equals negative 1/2 x minus 2, could you tell me what the y-intercept of this equation is?
Yeah.
What is the y-intercept?
-1/2.
Negative 2. What is the slope?
Intercept, sorry, wrong one. -2.
If I asked you to graph this, could you graph this? what must you graph first? Can you graph the slope first?
No, the y.
You have to graph the y-intercept first, okay? What is the y-intercept? What does the y-intercept mean? What is that?
The y-axis.
It's where it crosses the
Y-axis.
y-axis. In this case, it's what? -2. What was my slope?
-1/2.
My slope is -1/2. What does that mean? That means I'm going to make my top one negative, my bottom one 2. That means I go down and then where? Over.
Right.
From here, right? From the origin?
Down.
I go down 1 over 2?
Yeah. No.
No, you
No.
start from the.
I go from the
Dot.
y-intercept. That's why you have to graph that first. So I go down 1 over 2. And then I make my line.
So they'll all be
Say what?
there will already be a.
There will be a graph there, okay? You better know how to graph that, okay?
Is that all we need to know about slope? Like on the test? Because we had like a whole section on slope, but is that like.
Yeah, well, hold on, I'm not done yet. Okay, what if I have an equation like this? Okay, continuous slope-intercept form. Let's say I gave you this. And I told you that you need to put this into slope-intercept form and graph it. Okay, I need to get what by itself? Y. So I'm going to, oh, this is 6x, sorry. I'm going to take away 6x from here and from here. So I have 3y equals -6x minus 12. Y still not by itself. How do I get y by itself? Divide everything by what? By 3. By 3. Okay, guys, I don't know what's wrong with me this morning. I need more coffee. Okay, so that gives me y equals, what's -6 divided by 3? -2x, what's -12 divided by 3? -4. So can I identify my y-intercept of -4 and my slope of -2 over 1? Okay? All right. The only other things you have to know for your test, okay, is you need to, and this is the last part, okay, this is what we just finished. You need to know about how to graph a function, okay, a function table, which we just finished, so I should not have to go back over that. Function table, completing the function table, okay? And then you have to know how to graph, I'm almost done, a linear function. What's a linear function going to do?
Straight line.
Straight line. And you need to graph a non-linear. What is a non-linear going to?
Not or a parabola.
Yes. Okay? That's what's going to be on your test. Is that difficult?
No.
That's all that's on there. Okay? You know what I would love? I would love for everybody, if everybody gets an A or B on the first one, okay, then we don't have to do it on Wednesday and Thursday. We'll watch a movie or something, okay? It might happen.
It might. It's
I have faith in you.
possible.
I don't know.
What if we take the third day?